One thing he does is he ends his class with some magic, card magic. So that's why I have this Harry Potter t-shirt. Now, the kind of things he teaches, he is an economist. Last decade, still there. So, kind of things he teaches are extremely important, not just for economics, but as I was saying, for many areas in climate, including, for example, infrastructures, coupled human natural systems, and also to the very heart of what we are trying to do, or with working. So pay attention. It's extremely useful, and as a special treat, as I said, if the students are more or less nice and ask good questions, then it ends with a party. So one other couple of announcements or questions I had. I was talking with the PAs. Last time, at the end of the dialogue, many of the students came to me and said that, we thought we'll learn a little bit about AI and machine learning, that sort of stuff that you said you do, or we saw somewhere that this lab does, generative AI, machine learning. So it came a little bit at the end. We tried to do a little bit. We cannot teach everything about AI and machine learning in a private course. We can teach a little bit, and we can talk a little bit about some of the things we do in that area. But since it came at the end, we gave a little bit of introduction, but not much. This class, I haven't heard a lot of that, and each class is different. Can I get a sense of, is that something that's on the top of your minds for any reason, AI, machine learning, generative AI, if it is? Okay, so I see a subset. What we can do is maybe we can have some special session, because I don't think many are interested, which is fine, this is a private course. But what we can do is, with whoever is interested, we can, do some special discussions, sessions, exchange of ideas. And same with others. If you are interested in any specific topic, let us know earlier rather than later, and we can do something similar. Okay? All right. With that, did I miss any announcement? No, you're okay. All right. I know the PAs are working hard to put everything up on YouTube. So hopefully it will be up there soon, right? And once it's up there, they'll let us know. All right. With that, if you need adjustments right now to the temperature, please let us know. Warmer, cooler. Okay. First, adjustments are needed at this point. Anybody wants a little bit, anybody wants to exchange places with some place which is a bit cooler? So the thing is, he's right there, friend, I can see that. Okay, you have.
I can move if you want to.
Okay. So at some point, you could change that. But if it changes at some point, let me know if you need to be. The shades are an experiment during the break, and if it works. Okay, with that, over to my friend for economics. Oh, climate change policy. That's going to be easily explained. Great. Okay, go ahead. Rajarshi, thank you very much.
I think I am audible enough. I don't need to hit the mic. Okay. Thanks, Arup, and thanks to all of you for inviting me for this lecture. Now, there are 96 slides. I will skip video.
What happened to the other 4?
So the other 4 I left for sort of comments from this class so that I can add it for the next dialogue.
This class is as good as the
Next one.
other classes, so you shouldn't have taken out the other 4.
So, well,
by the way, just by way of background, this guy and I, unfortunately for both of us, go back a long way. So you'll see some of this thing. Please, Rajarshi, take it over.
like with climate change and climate change science, there comes another aspect of it which we call the climate change policy. And one part of this dialogue is understanding how policies work or why policies do not work always. And as we from the social science background see that yes, there are technological solutions, but the problem lies in adopting them because the economics of climate policy does not make it a optimum choice or a beneficial choice for many of the agents or many of the stakeholders. So today we will try to sort of run through why climate change policies are not universally acceptable and why there are some issues with adapting climate change policies or actions which look very good from the theoretical, scientific, technical point of view. But first, I always start with the past or the story of the civilizations. And around say 4000 BCE, among other civilizations, there were three civilizations around Asia, the Asian subcontinent. The Harappan civilization around Indus and its tributaries, that is more or less the river from which India got its name. Then the Mesopotamian civilization, which was around the Caspian Sea, Black Sea area, which was fed by the two great rivers, Tigris and Euphrates. And we also had the Dravidian civilization, which was the Deccan Plateau region of India. And for contextual understanding, this is something like which you can relate to, that we had somewhere here, Bangkok, the Gulf of Thailand area. This one over here is the area of the Indus Valley civilization. This one is the Mesopotamian civilization around Caspian Sea and Black Sea. And this part of India, the Deccan Plateau area, was the Dravidian civilization. Now all these three civilizations were dependent on rain, specifically the monsoon rainfall, for its growth, development, economic activities, social activities, all of these. The difference was that the Dravidian civilization was mostly a hunter-gatherer society at that point of time. The Mesopotamian civilization was dependent on agriculture as well as on trade and also on what we call the marshland and the common property resource that you get from such ecological resources. The Indus Valley civilization was so-called much more urbanized with planned cities, manufacturing going on, and also the hinterland providing it the agricultural sector. Now, somewhere around 4000 years ago, like around 2000 BCE, the seasonal rains started to falter. It started to decrease. Now, these three civilizations reacted in three different ways. The Harappan civilization, how they reacted to the decrease in rainfall and therefore lack of water in the lower stretches of the river, was that they started to fragment the cities and started to migrate northeast towards the upper stretches of the river or towards the Himalayas. Now as they migrated, as they broke up and migrated, what happened was that they migrated along the lines of the subsections of the city. And the city was planned in such a way that people from specific occupations lived in certain quarters of the city. So there were the quarters for the manufacturers, there were the quarters for the weavers, there were the quarters for the blacksmiths and goldsmiths. So when they broke up and they migrated, people of specific communities, occupation went together. As a result of which, what happened is that when they settled in the upper stretches, they could not rebuild the cities. There are only specific communities, specific occupations in certain villages which they set up, and so that gave rise to what we call the decline of the Harappan civilization. The civilizations actually disappeared. Whereas in the Mesopotamian civilization, how they reacted was that when they found that the rains have started to falter, they started to tap the water resource, especially during the rainy seasons. And they started what we call storage and canals or the irrigation system. And that irrigation system, if you look at some of the old pictures and some of the old drawings that we have discovered from there, is that also led to a very great amount of social organization. Because when you have irrigation system, you have to have a system also of how the water is to be distributed among the different channels, among the different farmers, how the schedules will be of channelizing water, when should the dam store water, when it should distribute or release water. So that gave rise to irrigated agriculture, irrigation-fed agriculture, and also some kind of a social cohesion. And that gave rise to what we call increased productivity and therefore development and spread of that civilization. In the third case, the hunter-gatherer society of the Dravidian area, they found that when the rains decreased, the forests, instead of having big trees, a lot of supplies in terms of fruits and other vegetations and animals for them to hunt and gather, were replaced by bushes, shrubs, lower level of trees, and something like the forests became much more scattered and could not offer them enough food. They turned to settled agriculture. They started to sow seeds, tend to the crops, look after them and harvest. And that started what we call settled agriculture and settlements in the Dravidian society. So, what do we learn from this? We learn two things, especially. First, climate change is real. It has happened historically. And even great civilizations which thought that they are defeatable, if they did not adapt to climate change, did not react in an appropriate manner, they would disappear. The second and the third one, the Mesopotamian and the Dravidian, they could adapt to the changing climate, so they stayed on, they flourished. Whereas the first one, which was perhaps the most developed of that period, could not adapt to the changing climate, and therefore it disappeared. So now
One short interruption for, if you're thinking the Americas and civilizations and climate, one other civilization you might want to read about at some point is the Mayan civilization and how they reacted to shortage of water and droughts, etc.
Yes. So what we try to underline with these short 3-4 slides is that, see, now when we think of human society now and human progress now, we think that we have mastered technology and there are technical solutions and technological solutions to all of our problems. All natural calamities or all natural events can be controlled by us through technology. But that is not always true. We must try to read into what the nature is trying to signal and then try to adapt to those issues. And that makes climate change science and climate change policy much of a necessity today rather than just thinking that they would go away. Now if you come to present, that why then we have, if this is so, if this is so evident that we need to have climate change policies, why do we still have sort of debate and conflict between different types of countries or different countries in terms of climate actions or climate policies? For that we know in general something called the environmental Kuznets curve, right? All of us here at least know about the environmental Kuznets curve or the EKC. Loosely,
Let's not make that assumption.
okay.
It's an interdisciplinary group.
Okay. So that's why I was trying to explain it a little bit. For those of you who are uninitiated to environmental Kuznets curve, it is something like a loose empirical observation by Simon Kuznets that as a country develops or its per capita income increases, pollution level or environmental degradation level first increases. So development takes place at the cost of nature. Only after a critical level of development is achieved, beyond that further development takes place with lowering of the levels of pollution or lowering of the levels of environmental degradation. So it is more of a nature depleting in the first phases of development and nature conserving in the second phase of development. That is loosely what the PKC tells us. Now, this was an empirical observation from a long historical cross-sectional country-wise study, but we try to posit here that why do we have such kind of a relationship that would give us an idea about why there are conflicts between the countries. Is that okay? I mean, as an introduction to just PKC. Well, so I will not go into the so-called climate change facts and greenhouse gas emissions, etc. If we look at historical trends of greenhouse gas emission, we find that there is a clear correspondence between the rise in global GDP, global production, global population and energy consumption, especially fossil fuel energy consumption. And that started from around late 19th century, 1880, 1900 onwards, and which essentially picked up in the post-Second World War period, that is after 1950. Now what are the implications of these two time points? 1880, 1900, that was what we call the first industrial revolution, when large-scale industrialization happened, starting from Britain, Western Europe and the North Americas. So that was a critical jump in consumption of energy, because human activities, economic activities, production activities went from the household-based workshops to factories, and therefore consumption of energy, especially coal at that point of time, increased manifold. So what happened after 1950 is that a large part of the so-called colonized countries, the third world countries, got independence after the Second World War, including India, many countries in South Asia, Latin America, South Africa. Now, when these countries came into their independent existence and economic policy making, they looked at a template of industrialization from Western Europe and America, that large-scale factories, industrialization is the way to achieve higher income, higher GDP within a short period of time. So that also led to a quantum jump at that point of time in global industrialization and therefore global energy consumption. And these are related to what we call carbon emission at 2 breakpoints and global warming during this period. But then why we look at the production side of the policies? See, if we...
One other interruption. So, Rajarshi was talking about colonization and how previously colonized countries then tried to adapt to, in terms of technological change, etc., tried to look at the West. Thailand was never colonized, right? So Thailand means land of the free. However, like I was saying, one good thing about this part of the world, especially and including Thailand, is this country and this culture is very much willing to adapt based on various influences, resources, right? In a way that maintains their self while also assimilating things from elsewhere. So one of the King Ramas, I forget which one, I think it was Rama 5, I could be wrong, I mean you can check that, was the first to go from here to the West and study in the West, and brought some of those ideas which could help. So I mean every culture at different points in time offers opportunities which could help, right, the entire world. And he brought here things that could help Thailand from the Western world without hopefully trying to bring in some of the negative influences at least. So Thailand, despite being not colonized and land of the free, did get influence from the West in that. Okay? Please, go ahead.
So if we start from a situation where we say...
Can we do a quick introduction? Professor Deepa is also an economist, and both of them did their economics PhD from there. PhD from Jawaharlal Nehru University, both of them, and they teach in different parts of Eastern India now, and they also happen to be spouses.
Hello.
Thanks for joining. So you can ask, if you have questions, you can ask either of them.
That gives me an opportunity to deflect questions to someone, right? I mean, Arup's comment right at it. Okay, so see, if we start with the premise that from dust to dust, like everything that we have around us was at one point of time extracted from nature. We call many things man-made or synthetic, but if we go deep down, we find that it started with some natural resource. So if we think of the whole world as something like an industry, of a production unit, it started with some amount of nature over here. In the 1-2 axis, we measure natural endowment. So it started with some amount of nature, and it started converting those natural resources to commodities. So the more commodities we want, the more we take from nature, nature is depleted. So this is something like a production possibility curve, a pathway of how we move from natural resources to commodities. And the more commodities that we have at our command, we say more developed we are, more rich we are. So this is the path. So this pathway did not have any problem as long as the rate of depletion was small, because nature renews itself. So as long as the rate of depletion, rate of extraction from nature was small, it was not a problem. But when it started to come over here, when we have depleted much of nature, we find that the rate of renewal is not keeping up with the rate of extraction that we have. So nature is getting net depleted. And then, scientifically, from the basic sciences, it came around that, well, there is a critical minimum. If you deplete nature beyond that, then nature will not renew itself anymore. The renewal will stop. And that is what we call the carrying capacity. That if you deplete nature beyond that, there is no way you can get back to natural resources or natural endowments anymore. That would be what we call the end of the story for our blue planet. Now then, when the movement was somewhere here, concerns were raised and people started to say that, okay, we must stop. We must not deplete nature. The demand for commodities. And that demand for commodities is what the producers try to adapt to. So if in a country there is suddenly a demand for, say, iPhones, so production of iPhone would increase. If on the other hand there is a demand for, say, printed books, then books should be printed rather than being sent out as Kindles or EPUBs or those kind of things. Now, with social preferences, there are two things. One, too much of anything is bad. So this is what we call in economics the law of diminishing marginal utility. On a very hot day, you come into a store, the first unit of cold drinks, ice cream, glass of cold water is very valuable. It gives you lot of satisfaction. Once you have that, the second glass or the second cup does not have that much satisfaction. And once you have 2 or 3 glasses, well, you are more or less saturated. You don't want to have another glass of water. Right? That does not have any value. So this means that the more of anything you have, the value of another extra unit goes on decreasing. So this is what we call the law of diminishing marginal utility. The additional utility, benefit, value that one additional unit gives to you falls if you have more of that commodity. Okay? Any questions? The next is that we can mix and match. Like 3 pizzas and a burger gives you the same satisfaction as 2 pizzas and 3 burgers. So we can barter, right? That's the same old story. That you have something, you have 3-4 kind of things, and the thing that you have more with you, we exchange. We exchange with our friends, right? I remember in our childhood, in school, we used to exchange what? Cigarette cartons, matchstick cartons, stamps, right? Those of you who are affiliated, you know that we exchange stamps, right? We have a specific stamp, 2 or 3 copies, we exchange that for something we do not have. So, we mix and match, which gives us the same level of satisfaction. That gives rise to what we call some kind of a preference function for the individuals and therefore for the society. For example, let us have 2 commodities. Let us spot it that as of this is nature and commodities. We have 2 commodities, pizza and burger. Someone who has this many number of pizza and this many number of burger has certain amount of satisfaction. The same satisfaction can be obtained if he trades some pizza to get more burgers. So X and Y, they are different combinations. Like as I said, 2 pizzas and 3 burgers and 3 pizzas and 1 burger. Both of them are equally satisfactory to the individual and to the society. If we inflate it now to have a social factor. So here, if we now come back to this specific one, we have nature and commodities. So for a society, for a country, they are equally satisfied if they have this much amount of natural resource and this much amount of commodities, or they deplete certain amount of nature to come over here and get more of commodities. Is that clear? You are with me, everyone? Okay. So now, what do these successive higher curves tell us? The successive higher curves tell us the level of satisfaction is more. For example, compared to X and Y, Z has more of both, right? So if it has more of both nature and commodities, it gives it higher satisfaction. So the higher these curves, social preference curves, higher is the level of satisfaction for the society. So a society would always try to be on as much higher curve as possible. For the society, for the country, this is what gives it higher level of satisfaction. Ideally, this should be the case, that the technological upgradation takes place and the society also moves from point A to B to C, etc., etc. But that does not happen. Why that does not happen? Because with technology you cannot move beyond the initial endowment of nature. You can at least use use the available natural resource more prudently to get more out of every unit of nature. You cannot go beyond this. So that is why the production curves do not inflate parallelly outwards. The second thing is that if we look at the social preference curve, we already told that these curves do depict our law of diminishing marginal utility. That is, the more of something we have, the less valuable it is. See, over this curve here, it has more of natural resource, less of commodities. So here the society or the country is willing to sacrifice this much amount of nature to get 1 unit more of commodities. If we take this base as given, right, as 1 unit, whatever be the unit. So it is willing to sacrifice this much amount of nature to get this much amount of commodities because it has more natural resources compared to commodities. Its commodity stock is much less compared to natural resources.
Rajarshi, we discussed in an earlier class about the rate of electricity consumption on the x-axis and the human development index along y-axis for different countries. And at some point, if you're going to come to that, that's okay. We can keep that for later. But I was wondering, just for everybody to understand, this curve that you're talking about, the use of nature versus commodities, is it completely orthogonal to, let's say, how a country like Sweden or Norway in Scandinavia uses nature versus commodities compared to US and Australia, which uses a lot of resources for roughly the same level or maybe even lower level of HDI? Is this curve completely orthogonal or is there a relation?
Well, see, this curve over here which we are showing is assuming things like tastes and preferences and geography. So these are issues which affect the position of this curve. So here we only have nature and commodities, or what we call per capita income, human development, whatever it is. But other than these two, the other things are thought to be ceteris paribus, kept constant, unchanged, they are at the same levels, that kind of thing. But as coming to Sweden and America, that kind of a thing, or even with Sweden and Germany, that kind of a thing, or say if we take Scandinavian countries like Norway and say France, these two kind of countries which are more or less similar in terms of their per capita income. Because of geography, Norway uses much more energy and electricity because it is much more colder. So that is why the position of the curves may be different for different countries. We will come to some sort of an example later, some graphics. But as of now, we understand that someone who has more nature and less commodities is willing to sacrifice more of nature to get 1 unit of commodity, compared to someone over here who has lot of commodities and less of nature. So now when they have lot of commodities, they are willing to sacrifice only this much amount of nature to get 1 additional unit of commodities. So these people here over here are more concerned about nature than commodities because they already have a large stock of commodities and a less volume of nature. So think of this in terms of developed countries and developing countries. Developing countries, less developed countries who have what we call unutilized natural resources are willing to tap those natural resources to get commodities, to get income, higher income level. Whereas countries which are already at a higher level of income, they now think of conserving nature. So these, along with the production curve, the social preference which brings up the demand, and the production curve which gives us the supply, leads to something like this. See, in the initial phases, as we said, the curves are much more steeper. So here the social preference curves are steeper. But at the later stages, when the country is much more developed, it has more resources, more commodities, they are much more flatter. So then the time path with these production curves inflating outwards and the social preference curve like this, then the time path would look something like this. Right? So initially what would happen? Initially they are willing to sacrifice nature to get more and more of commodities. Beyond a certain point, they start becoming concerned about nature. And now they want to replenish nature. Then our time path should be something like where we have more and more of commodities, but now it is not nature depleting in nature, rather it is renewal of nature which is much more important, or replenishment of natural resources which is much more important. So this gives us something like what we call the time path over a range of your historical start from this point and moving towards what we call a developed state. And that is the path which has been traversed by the developed countries also. The difference is that most of the developed countries, which we call developed countries now, the developed North Americas and Western Europe or OECD countries, they started much early. So now they are at this phase of their development pathway where they are concerned about nature. Whereas most of the developing countries, the part of the world which you were traveling to, South Asia, Asia, Latin America, they are at these phases where they are concerned about their raising their income level, raising their command over commodities, and they are not much concerned about nature. So this gives rise to what we call the economic policies. For the developing countries or low income countries, we have nature depleting economic policy. For the middle income countries, we have something like a balanced economic policy where they want to have a balance between both conservation of nature and economic production for raising their income level. Whereas the high income countries, they want to adopt now a nature conserving policy. And these economic policies give rise to what we call the environmental Kuznets curve, where the pollution level first increases because they have a nature depleting economic policy. Then when they have a balanced economic policy, it stabilizes. And then when they have a nature conserving economic policy, the pollution level or the environmental degradation level starts coming down. This is something like what we call a theoretical micro foundation behind the existence of the EKC or the environmental Kuznets curve. See, this therefore gives us an insight into why climate policy discussions at an international level, IPCC discussions or COP discussions, why they are always fraught with conflicts and rarely they end up with something what we call an unanimous policy resolution which can be implemented at the ground level. Why there is always a conflict between this set of countries who want strict environmental policies across the globe and this set of countries who want a relaxed environmental policy for them to achieve higher level of development by using natural resources. The issue of coal. For example, India says that we have so much coal which is cheap and which is our main source of fuel or energy. Why should we not use it? Because other countries which have traversed this path have at their corresponding levels were dependent on coal. They increase their level of income or production by using the cheap source of fuel. So why should we now not be doing that? So this gives us an insight into that kind of a conflict. So this is number one. And then if we look at, as I was telling that, the countries at different phases of development, how their emission GDP ratio looks like at different points of time. So we have UK, which I said first country to get industrial revolution. So their journey started much earlier, and by about say 1950-60, they had brought down their emission intensity of GDP or emission per unit of GDP. US was the next to follow, and then we have the two big players now in terms of both population, economic production and emission over here, India and China. And if we look at this in terms of per capita income levels, that at which per capita income levels they sort of reach their peak, we find that whereas the developed countries like US and UK had picked their emission intensity at much higher levels of per capita income or development level, you can look at that. For India and China, it is picked at a much lower levels. Right? So in a sense, through technological diffusion, these countries have been able to control their emission intensity of GDP at much lower levels of per capita income compared to the first set of countries which had to go through the whole process of trial and error of technological changes. So this is something again which is heartening to note, which is a positive note that even these big players in terms of carbon emission have started to reach their peak emission intensity, and most probably they will continue with such changes or declining emission intensity. But what is the problem?
So, Rajarshi, if you can please go back to that slide just.
This one?
No, the one after, yeah. Couple of points I wanted to make. So, one thing I would hope you'd also think about, I mean, we have been saying Thailand, land of the free, never colonized. Indonesia was colonized by the Dutch. And the kind of things that happens, I mean, these are two relatively comparable societies in same parts of the world, but the kind of impact that colonization has had and the after effects, lingering after effects, is something also that as part of your cultural immersion, I would encourage you to think. So here, for example, we have, the US came a bit later. US has its own history, and you are all aware of US history, so I'll not talk of that right now. But let's say if we think about the other three countries here, UK, China and India. So in the case of UK and India, for example, it is a clear colonization history, right? Colonizer and colonized. And in the case of China, it was not directly colonized, but basically the country was drugged. So opium was grown in India and other places and shipped to China, and when the Chinese king, for example, or the Chinese leadership tried to react to that, the entire European powers came, had a major war, and sort of, finished off that rebellion, if you will. So before colonization, these two countries or regions of these two countries, if you will, were among the top, had the top GDP, potentially GDP per capita also, maybe definitely overall GDP in the world. And that was partly because of the population, partly also because of the level of development. There are some estimates which say, for example, that British colonization robbed India of $45 trillion. It's hard to imagine, mind-boggling number. And in the last 40 years or so of that period, killed about 100 million Indians. Right, so that's the extent of this. And that's what then causes various other things and has various lingering side effects. Now, interestingly enough, and Dian, please correct me if I'm wrong, the way colonization works is also, or used to work, is also different in different parts of the world. So, in India, for example, the British tried to create some people who they wanted to serve their interests. So they thought it to be in their interest to teach some people English, the language, and English culture, and try to make them closer to that. In Indonesia, the Dutch thought that the native people of Indonesia were much at a lower strata compared to the Dutch, so it's not even a good idea for them to learn Dutch.
Some of them. So,
Right.
yes, so different caste. For the king family, still
Yeah.
learning.
Royal family is different, but how many are those?
Oh yeah.
Right? No, but you're right. So we should talk more in depth. But this is a very broad, at the risk of some broad generalization. So even, first of all, there is colonization versus drugging the country, which has different effects. Then there is different types of colonization, which also has different effects. So as you think of these things, and as you think of how countries interact with each other, even now in terms of, let's say, Paris agreements, climate agreements, these kind of thoughts are still very raw in people's minds, right? In the minds of leadership, for example. So that's where these things come in, that not only these things come in that per capita income is different, and not only those things come in like Rajarshi is saying that things have peaked, differently and so on, but also the historical context comes in significantly. And that's where there is a need for everybody to understand that we can learn lessons from the past. We shouldn't erase our past, hopefully, but we cannot change the past. Right? There is somebody, how many of you have heard about Noam Chomsky? He's supposed to be the second most quoted person after Socrates. So he's a linguist. He was at MIT. And then he also has very strong political views. Some of you may agree, some of you may not agree, that's different. But Noam Chomsky made an interesting point at some point. So he himself happens to be Jewish, and he is in the US. So somebody asked him that you always criticize US and Israel and how Jewish people can do better. Is the US and Israel and Jewish people, aren't they the only ones to blame in this world? You are seeing what is happening, right? I'm not talking about, let's say, the last few months. Ignore that just for this discussion. That's another very complicated thing entirely. But I'm saying even earlier, so he was asked this question. He said, of course not. But that's where I have the most influence. So in the sense that me criticizing somebody else, some other culture, I have no influence. So each culture must have their own people who are criticizing themselves. That's the only way to make change. Me criticizing some other culture has the same influence as me criticizing something that happened in the past. Nazism, I don't think any of us here think, or most of us think of that as evil, which is true, right? It's one of the most evil things that happened. But we should learn from that, criticize in the sense of, okay, that shouldn't happen again, etc. But we cannot influence what already happened. That happens. All we can do is learn from it. So the same kind of things here. And as you think about these war games, which are sort of mitigation war game, especially in this context, which is a mock version of what actually happens at these agreements, right? Conference of parties. All of these historical contexts, this culture, the history, historical baggage in some cases, historical lessons learned in some other cases is important to remember. And that's why in this course, the dialogue overall says that cultural immersion has to be deeply embedded, and then there is, in addition to content. But in this course, it's not just, it has to be deeply embedded, they are strongly interconnected. Sorry for the interruption, Rajarshi, please go ahead.
It gives much broader perspective to what we are discussing, and maybe sort of drives in the point that why we need to study the situation of different countries at different levels. And of course, as Arup told, that the cultural immersion part in Thailand and Indonesia would give them some insight about how the economy works and what are the drivers of the economy in Thailand and how it is different in Indonesia. When you visit that country, you will find that difference to be very pronounced, that okay, these two countries have their economic basis or drivers of the economy at completely different sectors, and so that also drives their environmental situation, environmental policies, and what they can compromise with, what they cannot compromise with. Okay, so this is something like, again, what you are familiar with in terms of climate actions and global warming, that global annual carbon emission is going to look something like this. This is somewhat a business as usual scenario of how total carbon emission is going to rise over the years, starting from today over the next 25 odd years. If the countries, at least the two major Asian tigers like India and China, are to converge with UK and USA in terms of their per capita income, that is, if India and China are to grow at about, say, 10 to 12% per annum for the next 25 years, then the amount of energy consumption and related carbon emission would look like this. But still, this is not the major problem. The problem is that So as I said, if we look at the present, what are the lessons up to this point? That it will depend on the economic level of the candidate. Candidate here may mean a farm, a society, a country, or even a subcontinent. So the economic level and the economic background of that country, along with the cultural and historical context, will determine the climate action. And it is dynamic. It will change over time even for the same country. And therefore it is very difficult to arrive at a national or global consensus. Now then what do? We said about what we call tunneling through. That we move directly from these developing countries, move directly from this point to this point without peaking their emission levels. And that can be done only through what we call technological advancement in those countries, and that is why there is always a cry for technological diffusion from the developed West to the developing countries. The whole COP talks of these things, that a fund is to be set up through which developing countries will be provided patented technology from the developed countries so that their production process becomes much more environmental friendly, much more green. This is one way of looking at that. So for that, I think Professor Rajarshi had gone through some of these things, right? The Kaya identity and the, no, she has not gone through this.
She talked about something else entirely, like societal well-being.
Okay. So see, if we now try to look at the greenhouse gas emissions of countries, we can break it down to several parameters. Through simple algebra like cross multiplying, etc., etc., we have greenhouse gas emission. This is our concept. How to manipulate greenhouse gas emission of particular countries. So see, we can just break it down to things like this. If we have greenhouse gas emission divided by the total energy consumption of that country. So this parameter is known as carbon intensity of energy consumption. That what is the total amount of greenhouse gas emitted per unit of energy consumption. So obviously this will be higher if the most amount of energy comes from fossil fuel. This will be lower if a large part of energy consumption comes from greener sources like hydroelectricity or solar. The next part is energy consumption by the GDP of the country. So energy consumption by GDP is what we call the energy intensity of GDP or the inverse of energy efficiency. So the higher is energy efficiency of the country in terms of technology, etc., lower would be this energy by GDP ratio or energy intensity rate. The third factor is GDP by population, which is nothing but what we call the per capita income or the average income level of the country, which is a measure of the development level of the country, etc. And then we have population. So you do this multiplication, you get greenhouse gas emission. So therefore, greenhouse gas emission of a country depends on population, energy intensity, and greenhouse gas intensity or carbon intensity of energy. Now, if we do a simple log transformation and differentiate with respect to time, without going into the maths of that, what we find is that growth of greenhouse gas emission year to year is a sum of four factors, four growth rates: population growth rate, per capita income growth rate, energy intensity growth rate, and carbon intensity growth rate. So these four growth rates added together gives you growth of greenhouse gas emission. We are worried about that factor, right? Greenhouse gas emission, how it grows year to year for a country. We try to put a brake on that. So to put a brake on that, we have to put a brake on these four. The point is that population growth rate is more or less outside the boundary of environmental economics or environmental policy makers, and it is more or less stabilized across the globe except part of sub-Saharan Africa and part of Latin America. Per capita income growth likely to be very high because a large part of the world are still at a much lower levels of income, like as I said, India and China, they would look at something like a 10% to 12% growth rate of per capita income to reach the levels of developed countries in say about 30 to 40 years. So that leaves us two things: energy intensity growth and carbon intensity growth. These two have to keep as low as possible, negative, so that greenhouse gas emission can be checked. Is this clear?
So I understand the first derivative part, but why are we taking the natural log?
Yeah.
Oh,
Why we are taking a natural log?
yeah.
So we get natural log so that after differentiation we get them as growth rates. Since these were as a product form, to make it an additive component, we have taken natural log, so that the product forms transform to a additive form. So now this growth rate becomes a additive function of 4 parameters.
Why is that important to make it additive? I mean, is it just for algebraic convenience, or is there?
Number one, it is for algebraic convenience that we now have a linear form of the greenhouse gas emission. The second thing is that once it becomes additive, we can say that now if one is positive, is high, we can balance it with something else which we can pull down and make it negative. So since it is something like 4 blocks, additive blocks, give rise to that greenhouse gas emission as something a column. So if some of those blocks are pretty thick or high, we can track down some of them to be thinner, slice them, so that the column of greenhouse gas emission growth rate is low.
I mean, so that's not really convincing to me, in the sense that what you can do by addition, subtraction, you can do by multiplication, division. So does it make it easier to communicate?
Yes, that's what I said. The first thing is the algebraic convenience. The second thing is that when you have it in terms of additive sense, we can look at it, we can visualize it. That these are 4 blocks that are added on top of one another to give rise to this massive column of greenhouse gas emission growth. And so if one of those blocks are pretty thick, we can balance it by slicing some of the arms.
That makes sense. Does that answer your question somewhat?
Yeah, I guess on the slide before you had, can you just show the slide before? Yeah, you have them multiplying together, and so I guess I'm confused how they're equivalent, because you took the natural log of both sides, I assume.
Yes.
And so I'm confused on how you took the natural log and then got an additive form.
So if you take natural log of this product form, because they are in product form, they can be separated out as additions, right? Like
Okay,
log
got
A
it. Yeah.
times B is log A plus log B.
Right, okay, got it.
Yeah, so now the problem with the last one, that a large part of world is still to be energized, and most likely once they are energized, we will have again a second round part of energy consumption and associated carbon emission at the global level. So therefore, as I said, that the two instruments in our hand are to bring down energy intensity growth and carbon intensity growth. And the first one, bringing down energy intensity growth, is known in the literature as decoupling. Decoupling of economic growth from energy use, which means that economic growth will continue, but this will not lead to a rise in energy consumption proportionate. So energy consumption would be decoupled from economic growth, so that countries can develop, can grow economically, can increase their production income level without proportionate increase in their energy consumption. The second part is known as decarbonizing, where the carbon intensity growth is negative or is very low, which means that energy consumption is there, but we are shifting towards less carbon intensive energy. We are shifting from dirty fuel to cleaner and greener fuel, so that the carbon emission is low. So these are the two instruments which we now have in terms of policy. So when during your war games you sort of sit together for your writing up contracts and writing up declarations, and you bargain with each other. These two are the instruments that you have to look at. Let's keep these two. Okay, then we are halfway through almost.
The magic, we still have the magic, right? The magic show?
Yes, the magic is we'll have it. Well, so now in developing countries, what happens? These are the two aspects of climate change policy, right? One is mitigating, one is taking steps to prevent, which are unmanageable, and adaptation, which is managing once something has happened, managing what is unavoidable. And taken together, they form what we call the resilience of the society. And both of these, mitigation and adaptation, they require resources, they require planning, they require decision. And if we try to understand these, then we can identify why these things are generally at a lower level in developing countries compared to developed countries. You see, whenever you want to take a climate action, for example, bringing down pollution by caps on industrial units or caps on industrial production, that okay, you cannot pollute beyond this level, or you have to install some kind of a pollution decreasing devices in the chimneys, or you have to shift from this kind of a fuel to that kind of a fuel, or in terms of adaptive mechanisms like construction of a dike in the seashore, or something like a stormwater drainage channel, or say a resilient infrastructure which will be resilient to cyclones, etc. Now all those climate actions are costly. They create a benefit by cutting the losses or increasing net profits. So whenever there are climate actions like that, at the decision level, you have to compare between the potential benefit and the costs. And it requires some kind of a cost-benefit analysis. There are specific tools of cost-benefit analysis and mechanisms. We will not go deeply into that. But let us just understand this, that faced with any kind of an environmental disaster or challenge, we have some alternative mechanisms, including a mechanism of not doing anything. So not doing anything vis-a-vis doing something, and when we decide to do something, there may be options like A, B, C, etc. So when we compare these alternative actions, we have to think of the cost of that action and the potential benefit. And the net of potential benefit less the cost is the net potential benefit. And ideally, we should choose that action which maximizes our net potential benefit, that is potential benefit less cost. So how to do that? There are two ways of doing this. One, technical efficiency. So we are looking at 2 or 3 different alternatives, and we want to check whether they will be able to perform the job that we want to do. For example, construction of a dike. So will the dike be able to prevent seawater from flooding a coastal area? So the technical efficiency of the dike is to be studied. The second thing is economic efficiency. Economic efficiency is where we want to study whether it is at all economically justified from the point of view of resources, from the point of view of money spent and the money saved, to have that kind of an action. So there can be several alternatives which are technically efficient. They will be able to perform the job in the physical sense, but which may not be economically justified because the cost of doing that is much higher compared to the benefits that would accrue. So at the decision making level, there has to be a confluence of physical scientists, who would look at the technical efficiency of the alternative climate actions, and social scientists who would look at the economic or social efficiency of the alternate climate actions. So we talked of maximization of net benefit, right? That net benefit is potential benefit, value of the potential benefit less the cost, and we want to take that action where our net benefit is maximum, highest possible. And net benefit is maximized when what we call in economics the marginal cost and the marginal benefits are equal. That is at a point when any additional action will have the same per unit cost as the same per unit benefit. So at that point of time we say that the net benefit minus cost is maximized, because beyond that if we do some additional action, we increase the intensity of our action or the span of our climate action, then the cost will be more compared to the benefit that we have. So that point is what gives us the optimum or the highest net benefit. But at the ground level it is very difficult. Why it is difficult? I will not go into resilience. Okay, let us spend a few minutes on this. See, this is something like potential benefit, what we also know as damage cost. That if we do not take any action, what will happen? So if we do not take any action, damage cost will be very high. For example, let us stick to the example of the dike. So if you do not build the dike, potential flooding, damage cost will be very high. If we build the dike, the higher is the height of the dike, less will be the damage cost. So the degree of resilience is what we call, say, the height of the dike. So higher is our degree of resilience, or higher is the height of our dike, less will be the damage cost. Because now less area will be flooded. So then, why don't we maximize this? Why don't we say that, okay, we build a dike of 16 meters height, because then our damage cost will be minimum. That will solve our problem, right? That, okay, let us minimize the damage cost, let us maximize the resilience, and build a dike up to this point, up to this height. In that case, our damage cost would be less, would be the minimum possible. There are 4 reasons. First, building resilience is costly. So the higher is the height of your dike, higher is the cost involved. Second, which is much more important, is that the damages are uncertain. You do not know whether there will be a cyclonic storm or a flood, or seawater will, storm water will rise up to that height, or flood will take place. So these are all uncertain. The events, the climatic events themselves are uncertain, so the damages are also uncertain. They may happen, they are possible, but they are not certain, and they happen in the future. So the third point is, damages are expected to happen in future, but costs are to be borne now. The dike has to be built now, the cost is fixed, certain, and it has to be now. Whereas the damage or the potential benefit, so the damage cost is our potential benefit, what we save against. So the potential benefit is one uncertain. Yes.
I guess I'm a little confused, because if you are saying we don't maximize resilience because damages are uncertain, then how did you come up with the curve to begin with? And then also, if it's going to happen in the future as a reason not to maximize resilience, isn't that type of thinking the exact type of thinking that gets us into the situation we are now with climate change?
Yes, that is what we are trying to explain, that why we are in a situation right now, that we know that there are certain actions that will help us to adapt to climate change, or to mitigate climate change, but we are not taking those actions. Because as I said, there is a difference between that it is technically efficient, it will do the job, but whether it is justified from an economic side of it. That is what we are trying to explain over here. Okay? And the other point is that how we get that curve is that, again, from a technical point of view, we know that if the dike is up to say 2 meters, then even if it is stopped by a flood, how much area will be flooded? So what would be the economic loss of the area? If on the other hand the dike is of 5 meters, then of course the potential area to be flooded would be much less. Because now all those floods which were between 3 meter to 5 meter will now be prevented. So the area flooded would be less and the damages would be less. So from that we can sort of hypothetically draw something like a damage cost curve, that as the degree of resilience increases, the damages, the cost of damages would be lower.
So the question is an excellent one, and
Yes.
There is a course I teach called Critical Infrastructure Resilience, not for undergraduates though, but which goes into some of these issues. But we should have an assignment with some of these, net present value and things like that. So there are several things here. First of all, it's useful to understand. Let's say if you have a Sandy-like event, Hurricane Sandy-like event that devastated New York City, New Jersey area, right? And let's say the total damage that was caused was 65 billion. I'm just making things up, right? And let's say the probability that a Hurricane Sandy will hit the area is, I don't know, let's say it's a 1,000 year event. I'm making up all these numbers. So let's say it's a 1,000 year event, so it's 1 over 1,000. So then in any given year, the damage, if you just the likely damage, likely risk, if you just calculate.
Can I intervene for a second?
Yeah. Yeah. Yeah, I know you're so.
No, so that I gave you numbers.
Yeah.
So you don't have to make up something like this.
But if you go back there, so we can come back to this slide in a minute. So you can calculate, 1 over 1,000 over 65 billion, or you can use the number that is going to come to. But the thing is, remember, this hurricane can happen every year potentially. And assuming the damage is going to be the same every year, which may not be true, how do you even look at that? Well, you try to calculate a net present value, right? And you get an economic cost. Here is how much I spend now, here is how much I have to spend. Now, in terms of the uncertainty part, there is an interesting aspect here. So it's not just that you are spending now and that prevents things from happening in the future, but what you are spending now to build that dam, let's say, make that dam higher, could also have been spent for education, just as an example. So it's not just that, the argument that Prof made is not just that in the future, if we make that case, then it's going to be like that. But also, there are other potential expenses we can do now. That's one of the arguments that's made. The other thing is the costs also are not the same. So, we have worked with, let's say, cities, it's one thing. If you work with agricultural lands, forests, it's another thing. We worked with the Nuclear Regulatory Commission. And for them, it's 10 to the power 9. That's the level of tolerance that they have. Very low, right? 1 over 10 to the power 9. That's the level of tolerance, because imagine what will happen if by some reason that is exceeded. You get a Fukushima-like event, for some of you who may remember, right? So it also depends on what is exposed, what is in the path of, let's say, the floods in this case. So a lot of things here. Just because something is uncertain does not mean that you cannot pay, but you have to understand that uncertainty, characterize it. You have to balance it with what the costs are, from the higher end of the uncertainty to the lower end of the uncertainty. And of course, you have to balance it with what other costs. And it could even be one dam here and one dam there, for example. Right? One dam to protect your nuclear assets somewhere else, and another dam to protect a city, another to protect an irrigated field. Just dams. And then there could be other kinds of costs. So there are reasons why you have to at least think of these things. Beyond the fact, which is also true, that some people will make these arguments. So then how to get beyond these arguments, how to characterize and what to do with that, I'm assuming that's what you'll come to, right, Rajarshi?
Yeah, I'll just,
Those are the kind of things you'll come to.
yeah, because
So that's a good
that
question.
is what I'm trying to point out, that these are the questions that are raised by mostly the developing countries and developing societies when they are facing climate actions. The fourth thing is that structures are finite lifetime, right? Benefits are not perpetual. So there is a finite lifetime up to which we can get the benefit. So if a dike has a lifetime of say 20 years, so we will get the potential benefit up to 20 years only, not perpetually beyond that. So as Arup was saying, that there are different levels of the intensity of the climate event and the probabilities are different. So suppose the flood that we were speaking of in terms of the building of the dike, the intensity levels are 1, 2, 3, 4, 5. So higher the intensity levels, higher are the costs or the damages that it involves. But those high intensity floods do not occur regularly. So while intensity 1 flood, very low intensity floods occur every alternate year, a very high intensity flood occurs only once in a century. Okay? So if you have the damage cost like this, then we can find out the probability of that. For a given year, a flood which is supposed to occur every alternate year, so in any given year, the probability of its occurrence is 50%, half, right? So the damage cost is 1 million, probability 50%. So this is what we call the expected loss if we have a intensity 1 flood, 0.5. Similarly, for an intensity 3 flood which occurs once every 10 years, once every decade, it has a damage cost of 8 million. So if an intensity 3 flood occurs, 8 million would be the resultant damage. But it occurs only once every 10 years. So the probability of its occurrence in any particular year is only 10%. So the expected damage would be 10% of times 8 million, 0.8 million. So in this way, we can find out the probable annual cost, that in a particular year, what is the expected annual loss we are looking at if nothing is done. So if nothing is done, these are the expected damages with different probabilities. So this is the total. So this is what we call the probability weighted cost. Second, this is the expected damage cost that we just saw. So this is the third thing, that what Arup was telling you, present value. So they occur in future. So since damages are expected to take place in future, any potential saving that we will have will operate in future. So the dike has a 20-year lifespan. So every year it is expected to save, as I said, other things remaining same or the damage costs remaining same, around 3 million every year it is going to save. But those 3 million expected saving is not at this point of time. It is spread out over a period of 20 years. So then what happens? You have to convert that to present value. Yes, something like this. So the present value of benefits are calculated by something called a discounting factor. Now that discounting factor is different for different countries, different societies, different economies, different purposes. but there is some kind of a discounting factor which we call a time discounting factor. So whatever value we have in future is worth less today. So therefore we have to convert or denominate it with some discounting factor, say small d. Now for our hypothetical expected annual benefit of this, if we assume that anything in the future 1 year hence is 10% less valuable to us, if the discount rate is 10%, then of course it comes down to something like this. Fourth, as I said, they have a finite lifetime. It is not perpetual. So when it is not perpetual, then the present value function is again different. The present value equation is different, and it is more or less something mathematically comes to something like this, that if capital T is the total saving that you have, capital T is the lifetime of that infrastructure, and small d is the discount rate, then the present value would be something like this. D times 3t by c plus 2dt. These are all mathematical approximations that we arrive at, and I am not going to explain into those things. Just to give you an idea that what it depends on. So higher is the total potential saving, that is higher is the D, present value will be higher. Higher is the lifetime, capital T, higher will be the potential saving. Higher is the discount rate, time discount rate, time preference. Lower will be the potential saving. And again, the lifetimes vary across sectors, society, economy, and therefore the net savings are different. Now if we continue with our example like this, with the hypothetical example we were looking at, see, the blue line over here is the cost of building the dike. So higher is your level of the dike, height of the dike, higher will be the cost involved. And the red one is your potential saving present value. When you convert your potential saving to present value, that gives a curve like this. That if your height of the dike is 1 meter, then your cost is here, potential saving is this much. If you raise the height of the dike, the cost also rises, potential saving also rises, because now the dike can prevent high level intensity floods. And the two curves, because of the present value discounting and the lower probabilities of higher intensity events, they move like this. The gap between them is our net benefit. The benefit less the cost, which we started with our discussion. So this horizontal difference between the red and blue one is our net benefit. And we find that for our, again, hypothetical example, it is somewhere here. The net benefit is maximized. So ideally, even with the knowledge that a 15-meter high dike would minimize our long run cost, we do not find them to be economically efficient. That is why we say that when we look at the economic efficiency of adaptation techniques or tools or climate actions, we may find that it is not at the same level as the technical efficiency. So what is optimum, what is best in economic sense is not the same as what is best in a technical sense. There are differences between them. So these are again these mathematical examples. I will share the slides so you can go through that. So this is what we come to. See, as I told that there are two factors over there: the lifetime of the infrastructure and the discount rate. So other things like damages remaining unchanged, if we change these two, the lifetime of the dike and the time preference of the society, the discount rate of the society, the net benefit curve would change. So with something like our died whose lifetime is 30 years and the society's discount rate is just 5%, the time preference, then we have a net benefit curve which maximizes benefit over here at this resilience level. Whereas if the lifetime is less, T becomes 15, the same discount rate of 5%, T becomes 15, then the optimum level of maximum net benefit comes down. Also, with the same 30-year lifespan of the die, if the discount rate is 15%, that is, if the society has a very strong time preference of the present compared to the future, then it comes further down to this. So even the economic efficient level of climate action can be different based on the lifespan of the infrastructure of the climate action and the time preference of the society. This gives rise to what we call the different actions that we find in different economies, in different societies, especially the difference between what we call developed countries and developing countries. And I will explain that. So why therefore we find that resilience in developing countries are on an average lower? First, the perceived uncertainty levels are very high. There is very low awareness about damages from climate change and the potential benefit from climate actions or even the scientific forecasts. So this whole climate denial kind of thing is much more prevalent in developing countries because of lack of scientific knowledge. Second,
Rajarshi,
yes,
I beg to differ on that part. And definitely, I mean, what you said is what most of you think to be true. However, we come from the US, and what we have been seeing is very interesting. So to the extent, by the way, let me ask this class, how many of you think that the political spectrum in any part of the world, but let's say US, since most of us come from the US, so brief interruption, can be, at the risk of some overgeneralization, can be broadly categorized as the left versus the right. So some of you mentioned, I mean, in Joyshri's class, I mean, lecture, she was asking, she shared some opinion polls, and you know, what are the major challenges? So of course, climate change, poverty, many of these came up. One of the major things was polarization, and you know, it's very clear. So again, to the you know, with some generalization, or at the risk of overgeneralization, as I was saying, right versus left. Interestingly enough, what we often see is in certain developed countries, not all, but certain developed countries like the US, where it's very strong polarization right now, it's the right, of course, right, which do not either believe that climate change policies should be made, or then they start to criticize and go all the way to climate science. And again, I'm not talking about skeptics in the science of the science. That's not the people I'm talking about. I'm talking about deniers for some other reason, right? They have an agenda. So that's the right mostly in the US. Most of you'd agree with that, right? Interestingly, in India, and actually one of those we heard at your institute when I took the same, I mean, another batch of dialogue students over to your institute in India, it's often the left, and not just India, in developing nations in general, it's often the left that has problems. They come from another angle entirely. So their angle is, oh, but you guys have developed, oh, but you are this, you are that, and now you are imposing this to make us less developed. We cannot follow that same path. It's some form of neo-colonization. That's, I mean, I'm not saying I agree with that, but that's the angle they do. Interestingly enough, so when I went to, I mean, when we were having that discussion, I said, at some point I got maybe a little frustrated, not, I mean, I didn't show it, but I said, but I thought this is the land of Gandhi, right? We're trying to come together, not separate. But that feeling is very much there. So just wanted to mention, I mean, what he's saying is how it normally should.
No, again, this is something like a generalization terms of the citizen.
Yeah. West
Not in
Europe.
terms of camps like right and left
No.
and the lobbying forces.
Well, in the US, and that's why I wanted to mention this, that that doesn't hold anymore, unfortunately. In West Europe, it still does. If you go to the US, because there is so much level of polarization, and I have to check every box. So if I think I'm left, I have to check every box that's left. If I think I'm right, I have to check every box that's right. Otherwise, I do not belong. That is the level of polarization that has happened. It's hard to believe.
So then this is
You guys should
development
come one.
less one, right?
You guys should come one day and visit us in Boston, and we'll take you through various parts of US. But no, absolutely. I mean, your point is well taken.
In a sense that it is then developed countries less one.
Sure. It's less a few, yeah, but yes.
The less a few.
Yeah.
But still developed countries.
That and that one is where
And
we
what
are
is
coming from.
developed? No, then we'll have a discussion on me, you, Danish, and
Right.
Jan
What
will have
is
a discussion
developed?
on what is developed.
But no, especially since we come from that one, it's not just one, by the way, but let's say that's one.
Yeah.
Therefore, I wanted to set expectations.
Okay.
Go ahead, Raj.
So then what happens is that, as Arup mentioned at that point of time, that especially poorer countries and developing countries, they have different demands on their resources.
I should come back. No one can open except me. Sorry.
Thanks, dear.
So there are alternative priorities. Growth versus sustainability. That you want to spend more on primary health, where say kids dying from just preventable disease like diarrhea are about 150 per day. Every day 150, 150 infants and children die from diarrhea. So whether you want to spend on building that diet at all or building a primary healthcare center where literacy is say 60%, 65%, whether you want to spend on building a climate resilient infrastructure or a primary school, you want to build a road connecting the hinterland with the town, you want to spend on food security, etc., etc. So those alternate demands mean that there are always resource crunch, and every penny that you spend, you must be absolutely sure that it gives you the highest bang for the buck. So you must have the most economically efficient spending possible. And that leads us to what we call a situation where preparedness is poor, both by design and by default. Because of the alternate resource needs, because people have very high time preference for the present as compared to future, and alternative priorities. Let me share an anecdote with you. So as Arup was telling that I did my PhD from JNU at Delhi. Now the university is located at a very typical place which is called an extent of the Aravalli Ridges or some ridge and forest area of the capital city, and it is fairly green. So just behind our hostel room there are a few trees which has, as in seasons, they have these dry twigs, and some families from outside used to come, a lady used to come and pick up the twigs. And then we found that few days later or months later, we found that the lady is sometimes also breaking some branches to carry away as twigs. And then as young people, very idealistic kind of thing, we thought we should save the environment, save the trees, etc., etc. So 2-3 of us went and one day accosted the lady and told that, see, you can't do this and blah 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 blah, that if you break the branches, the trees will die and this belt will become sort of without trees, then what will you do? You will suffer because of climate change, environmental damage, etc., etc. So she patiently heard for about 5-10 minutes, and then told that, but see, if I don't carry that branches and twigs today, I will not be able to cook food for my children, because that is the only source of fuel wood to burn the chula or the oven. So for her, the present is so much more valuable compared to what would happen, say, 5 years, 10 years, 20 years hence, is what makes in most developing countries and poorer societies, again, at the risk of overgeneralization as I was told, that the discount rate is very high. And once the discount rates are very high, people tend to value the present much more compared to what will happen, probably happen sometime in future, is that the economic optimum level is at a much lower level compared to what it is in certain other societies or countries which are more affluent or which have much more institutional facilities to help the people. So as I said, that these are issues that come up. So what we need? We need to build awareness and confidence on the scientific discourse. We need to cut down on corruption from climate action, leakage, especially during built infrastructure, so that their viability is more, the net benefits are higher, so that we can have a higher degree of resilience or climate action. And then, as I said, that different groups have different time preferences. The story that I told, that even within a country there will be different groups which are different, as Arup tells, right and left. The different groups have different preferences, different choices. So how to negotiate between groups even within the country? For example, the industry and agriculture debate. I hope this time also they have groups like that, Arup, during war games.
Yeah.
Water and industry and agriculture.
So it's the same. There is a mitigation war game focused in this region with stakeholders from everywhere, and
By the
it's
sectors.
no. Mitigation war game is the countries like Thailand,
From
Indonesia,
from
US, United Nations. That's mitigation. Adaptation war game is by sector.
So while you are discussing the adaptation war games, you will find that you have the different sectors have different objectives, which are sometimes mutually conflicting with each other. So water resource, who will get the primary part of that? The agricultural sector or the industrial sector or the household sector? So that's where you have to think of negotiating between groups with different time preferences. Externalities, I should skip. Now if we come to therefore that what is happening in developing countries, I should end before going to the so-called card trick by Arup, that what are the main contours of climate change policy in India? Typically developing and one of the major players. India's climate policy is basically aimed at economic growth with climate sustainability. So it tells that it will follow its economic growth path, but try to build in climate sustainability within the economic policies. And for that, there are 3 demand-side energy policies that India has successfully adopted over the last decade or so, some maybe less than a decade. These are the Ujjwala scheme, which wants the rural households especially to move from firewood, biomass, coal to LPG, so that carbon intensity comes down. Again, the Ujala scheme, which wants people to shift from incandescent bulbs, which are much less energy efficient and much more energy intensive, to LED bulbs, which are about 5 times more energy efficient, giving the same amount of light from 5 times less energy consumption. And the FAME scheme, which wants to improve the share of electric vehicles. Now these are some of the achievements that India has made so far. So the target was something like moving 100 million households from fuel wood to LPG, which was achieved in March this year. and it is going on. And it is estimated that around 100 million equivalent CO2 is saved by this shift. For the Ujala scheme, so far the move from incandescent bulbs to the LEDs, it is saving around 50,000 million kilowatt hour every year. And the PAIN scheme, which is relatively new for converting, moving from ICE engines to electric vehicles, that is pretty slow. That is mainly because of price barriers. EVs are too costly in India, so even with the government subsidizing a part of that, they are still outside the reach of the middle class. And the charging infrastructure is also very poor in the country till now. Public infrastructure for charging is almost non-existent except states like Bangalore and Karnataka and Madhya Pradesh. So the move to EVs have basically been limited to cities and that too for the higher income class. So these are I think three things that I wanted to share. So if you have any questions, we can discuss that now before going to the games.
Yeah, card game. Yeah, any questions, please ask. The card game, please record very carefully. We want to find out his secret. I've been trying for the last 10 years. I've not been able to find out his secret. This time you record every angle, every move. But any questions before that? Anybody need a 5-minute break? Or should we just continue and end after the, just continue? Okay. Any questions? Anybody? Okay. Yes! The games. Let the games begin.